The vast environment of a chemistry lab is a harsh and unforgiving land for any specimen that resides in it. Today, I'll be taking you on a journey of life in this hostile environment. Welcome to the march of the molecules. A predator is on the move. Sodium cyanide. Sodium cyanide spends much of its life in a symbiotic relationship with sodium or other positively charged ions, which share a charge with one another in an anionic bond, muting the extreme power of the cyanide ion. However, under the right conditions, at the right time, cyanide becomes an aggressive predator. That time has now arrived. Monsoon season has arrived, and with it a great deal of rain. This rain is powerful enough to strip the sodium off of cyanide. The cyanide ion, now on the prowl, looks for an unsuspecting victim to stabilize itself. Nearby, an unknown molecule, the 8015Br, is battling in the cool savanna air. Another nearby predator, the weak nucleophile methanol, awaits from a distance, waiting to pounce. However, because methanol is weak, it must wait for a vulnerability to present itself when the bromine leaving group spontaneously departs from its victim. Unfortunately for methanol, the leaving group is on a premier carbon, an unstable location for a carbocation, and thus will be waiting a while. Cyanide, on the other hand, will not have to wait long. Cyanide sneaks up on its prey from its backside and ambushes it. It dumps its excess electrons into the antibonding orbital to tear apart C8015Br's bond to its leaving group in a vicious nucleophilic attack. Moments later, the SN2 substitution is complete. Cyanide is now firmly bound, happy to have resolved its negative charge. C8015Br's bonding configuration has been effectively inverted to make way for this new addition. Likewise, cyanide can be greatly dangerous to humans and as such must be contained. In each of our cells, there exists the electron transport chain, a pathway that the cells use to synthesize their most important molecule of energy, ATP. Within the electron transport chain exists a small enzyme known as cytochrome C oxidase, which is critical in the process of creating energy. Cyanide, when introduced into the body, will bind to cytochrome C, completely disabling it. This debilitates the entire electron transport chain, bringing ATP production to a halt. Without the energy to conduct the necessary bodily functions, death will soon follow. We thank you for joining us on this journey of the great power of the cyanide ion, and we hope you have learned some more along the way, including the mechanism of the SN2 reaction.